Atmosphere! Yeah, stuff.
All right, so we're going to talk about the atmosphere today.
Yes.
True.
Take it away.
All
Go ahead,
right.
Mr. Black.
So the atmosphere is composed of three main things. You got solids, you got liquids, and you got gases. So the solids would just be like dust, dirt, bacteria, ash. Yes, bacteria is in
So
fact
there's living
algae.
stuff in the atmosphere.
There's a lot of living stuff in there. So anything that's solid that's up there. There's a lot of it. There's tons of it. That's why clouds form. We'll talk more about that later. So liquids, mainly water. Hopefully, mostly water. There are other liquids up there too, like sulfuric acids and other types of particulate matter that forms into other liquids. And then you've got gases, mainly air. The interesting thing about air is a lot of people think that when we think air, they just think oxygen. Well, oxygen is actually not the biggest part of the atmosphere. That would be
Nitrogen.
nitrogen, right. 78% of the atmosphere is made out of nitrogen.
It doesn't react at all when you breathe it in.
No, nitrogen's pretty much not an inert gas exactly, but it's not very reactive either. And oxygen is only about 21%, which is important for us and for other living things because we need that, and for fire. But it's a good thing we don't have more because then we'd be in some
The atmosphere would be on fire, but we need to have enough oxygen to actually digest
True.
food and get energy. So yay for breathing.
And then the other 1% is basically a whole bunch of other trace gases like CO2, water, argon, methane.
Yep.
Lots of other ones too.
All right, let's talk about the layers. We're going to start, guys, with the farthest away from the surface of the Earth where we live. So we're going to talk about the outermost layer, the
Closest
layer
to space.
closest to space. Farthest out there is the first one we call the thermosphere. Thermo means like temperature or heat.
True.
And it's the one that absorbs
Like
most of
thermometer.
the heat, most of the energy, most of the solar radiation from the sun. It's the hottest layer. Just below that is the mesosphere, which is the middle layer. Meso means middle. It's actually the coldest layer because it's farther from the heat from the sun because that's absorbed by the thermosphere. And if you look at the layer below the mesosphere, there's a stuff in there called ozone that absorbs the heat coming from the Earth. So like the mesosphere is in a cold band, it just doesn't get a lot of thermal radiation.
Ozone, is that layer they always talk about?
Yes, we're going to go into that in a fair amount in this unit. It's an important part of our atmosphere is to know like what it does and why we need it.
Cool.
And it happens in the stratosphere. The next layer down, just below the mesosphere, is this place we call the stratosphere. It's calm. We don't have a lot of weather there. When you're flying in an airplane and they hit turbulence, sometimes they will go up into the stratosphere to get above that change in pressure area so it doesn't jostle the plane around. And that is the area where we have the ozone layer there. That does most of the absorbing of radiation, harmful radiation that comes from space to get us on our planet and do bad stuff to our living bodies. Troposphere is the part we live in. It's the lowest down atmosphere. It's where you see the clouds. You look outside and see the wind blow, or if you're like me on a day, you go outside and the wind blows your hair in your face.
That's gotta be a horrible
That's
message to
troposphere.
do.
It is a nightmare. It is a nightmare, but ideal because I'm strong. Troposphere is where all the weather happens there. That's really the stuff that we see when it's snowing, raining, whatever. That's troposphere.
Cool.
And that's down by us.
So-
Why doesn't space have any storms?
I'm guessing it doesn't have something.
What
No.
doesn't it have?
It seems like there needs to be air for there to be storms.
I would think
Because
there would be.
air is the movement. It's a very chaotic movement of air molecules. Look at that. No atmosphere in space. No storms in space.
Cool.
No sound in space.
Yeah.
You know that. All right.
Nice.
Well, anyway, so now remember way back when we've talked about pressure
Heck
before.
yeah.
Little
Now,
bit.
pressure is the amount of force that is exerted over a certain amount of space.
Yep.
Right.
Now, believe it or not, the atmosphere actually exerts some pressure on you. So, if you had to cross the ice without falling through, how would you do it? Why?
Yeah.
Well, you spread yourself out, right?
Right.
Because you want to spread that
Pressure
force
out.
out over a bigger space. It's like a snowshoe
Right.
or some big thing like sitting on top of the snow. It's easier to walk like that.
True.
We got a really cool demo we're going to do in class for you guys regarding pressure and surface area. We actually got a couple neat things, but one I'm thinking of is really fun and a little scary.
But, so, well, the air, like, so, all this atmosphere on us is solids, liquids, and gases. Therefore,
Right.
it's matter. Therefore, it has
It's
mass.
pushing on us.
It's
And if
pressing
there's
down
gravity,
on
so it
us.
has weight. The thing is, it's spread out. So,
Right.
Yes.
it's not this, you have millions and millions of pounds of air above us at all times,
Yes.
pressing down, but it is spread out. Now, that said, your body is adapted to having all that weight on you. So, believe it or not, there is weight on you.
So if you go on a planet like the moon with less atmosphere, you can jump higher because of less atmosphere and less gravity, right? We've adapted to this planet's gravity and atmosphere.
Yep.
Be like
So-
superheroes.
Now, this becomes important is when you have high pressure systems and low pressure systems in the atmosphere. high pressure systems will push towards low pressure systems.
And if you remember during Bernoulli, when we talked about Bernoulli, we delved into that a little bit.
But if only there was a really wicked, cool, and really flamboyant animation we could look at to show us high moves to low. Oh my God! That's amazing! I love that.
See how it went the way that the low pressure was? Because high went.
High kept chasing low no matter what. That was so cool.
I just am amazed. Like,
So
that's high budget stuff, man.
Cuckoo bucks.
So as I said, air pressure is the force that's exerted by the weight of the atmosphere
Right.
on you. Okay, and this is a great picture. This shows how, imagine all those little blue dots are
Particles.
air molecules.
Air
okay?
molecules and particles.
Now, since gravity pulls them down, there's a lot more air further down here than there is up there. Okay, so that's why if you go into a plane, they pressurize the cabin. They put more air into the cabin, seal it shut so it can't escape. Because if you're way, way, way up in the atmosphere, there wouldn't be enough oxygen for you to breathe.
So there's
also
a lot more
and also it'd be
oxygen
tough
down
for your
here
lungs to work.
because gravity's pulling it down. It has mass, so gases have mass. They fall down.
And it's also why, like, when people climb Mount Everest, a lot of times they bring oxygen with them because there's not as much air
Because
to
they're going
breathe.
higher up where the air is thinner. I've heard that, so they mean less
Into thin
air,
air.
less oxygen.
And in Denver, there's more home runs hit. But we can go into all these
Yeah.
details in class.
Well, but
But-
how do they measure this? How do they know these things?
Well, they use something called a barometer. Okay. Now this shows a pretty old-fashioned barometer.
That is
with,
old
like,
school.
Mercury in a bowl and everything like that, or not a bowl, but you know.
Yeah, in a
It
container.
gives you the idea, though.
But anyway, so a barometer is an instrument used to measure air pressure, and we measure air pressure in either millibars or inches or I've seen
Or
millimeters.
centimeters or millimeters.
Yeah,
or
millimeters of mercury. So
Hg is mercury.
because
on the
mercury is a
periodic
liquid
table.
that gets pushed down
Right.
by the weight. And
And that just goes back to, like, the good old days when they used to use mercury all the time.
For
because it
everything.
doesn't really evaporate too quickly, although
Nope.
it does gasify a little bit. But
Yeah.
we don't really use mercury for barometers
too
all that
much.
much
Not
anymore.
anymore,
no.
no, because it's pretty toxic. It'll
now we
mess your
just use
nerves
it in
up.
lights.
Yeah, and still not good. So we're going to talk a little bit about weather here. So we need to talk
Yep.
about when we talk about a front moving in and things like this, just so you guys get an
Right.
idea.
And all that really means is just it's a boundary that forms between two different air masses. of
So like
different
where the
densities,
wind
different
hits you.
temperatures.
So like
Right,
okay,
Different pressures.
So like
too,
if
maybe?
you've been standing there, like you may have noticed all of a sudden, like, wow, the wind just picked up. It's probably because a front just moved through. So you literally have a low and a high pressure that meet, and the high pressure pushes to low, and you create wind.
interesting.
Usually happens
so
at a frontal boundary.
Temperature and pressure changes cause wind.
Yep.
Neat.
Well, so we're going to kind of wrap this up though
Yeah.
by talking about big masses of air
Right.
and how they differ from each other. This
Yes.
is important because it does drive a lot of the weather that we're going to talk
Yeah.
about this year. Like
This
tornadoes,
slide is super
hurricanes, all that.
important, guys. Every
Definitely write it
comparison
down.
on here is very important. Like if you guys take a look at this, it sums it up pretty well.
Yep.
Yep. So first of all, cold air usually has a low amount of water vapor, which means it's not humid. If you heard the term humidity before, you'll probably have to write this down again at some point. But humidity
Yeah.
refers to how much water is in the air.
Right.
You
And
say
that's-
it's humid out, that means it's sticky. There's water in
There's a
the
lot
air.
of water in the
Okay.
air. So if we say it's not humid, it's kind of dry.
That's why in
Yeah.
the wintertime you tend to get dry, like you have to use
Yeah,
a lot more
'cause
lotion.
it's cold air.
It dries out.
And the
Your hands
warm
are
air
dry
is
and
typically
crackly.
more humid because it can hold more water.
And so the
Holds
summer,
moisture.
warm air is more humid than the winter.
Right.
Got it.
Now the next characteristic is cold air is usually more dense.
Which makes
Hot air
sense.
is
it's
less
cold,
dense.
it's packed
Yeah,
together.
we
The
said
air
how cold
molecules
things
have
are
less
together.
energy and they're packed together.
Right.
Hot air is less
Less
dense.
dense.
We're
More
talking
spread
old
out.
stuff. That
This
we
is
talked
old
about.
school. We know
It's all
density. That's
easy.
Unit 3. Let's move.
Cold air usually creates higher pressure, whereas warm air is usually low pressure, and that
This
has
must
to
have
do
been why
with
we talked about pressure a minute ago.
Oh
it
my
has to do with the way
gosh.
they move. Since cold air is more dense, it tends to sink or come down, creating higher pressure. Warm
Yep.
air, less dense, tends to rise,
Go
creating
up
low
and
pressure.
less pressure.
Makes sense.
Nice and easy.
So cold air, clear skies. Not a lot of humidity there. Warm air, cloudy skies. You got a lot more water in the air, which makes clouds.
And we'll talk more about that later.
Yeah.
You actually notice in the winter when it's really, really, really cold out, it's usually also really sunny out
Yep.
Yep.
because
Nothing there's to
Yep.
block it.
Hi, Jane Swanson, call 3363. Jane Swanson, call 3363.
all right,
And then finally, the sinking air, rising air thing that I already talked about a little
Which
bit.
makes sense.
I must be like clairvoyant
You're
if that
awesome.
was real.
More dense, sinks.
Yep. Less
Rising
dense.
air is going to be less dense. It goes up. We
Think
know
about
all
that.
this, guys.
Think about those like hot air balloons. They rise because they heat the air up, making it less dense and lifting
Take
it
some
up.
time to look at these 5 different contrasting points on here. It's going to be pretty familiar.
Yep.
And what do they have to do right now? Right
do
now.
your checkpoint.
Checkpoint, guys. Takes 2 minutes and it
Do
will
it.
help.
See you
Booyah!
later. See you later.
Bye.